Section 80.9c of the 2002 National Electrical Code states that where an existing panel board is replaced with a new panel board in the same location, the grounding electrode conductor shall be connected to the new panel board. Let's break down when a grounding electrode is required in different scenarios involving electrical panel work. Firstly, if you are only adding new circuits or wiring to an existing panel, you are not required to install a grounding electrode unless the existing panel does not already have one. Secondly, if you are changing the interior or feeders of an existing panel, you are also not required to install a grounding electrode unless, again, the existing panel lacks one. However, thirdly, this situation changes if you are completely replacing the panel in the same location. In this case, you are required to install a grounding electrode conductor to the new panel, regardless of whether the existing panel had one or not. Now, regarding responsibility, it is essential to understand who makes the final determination on whether a grounding electrode is needed. Ultimately, this determination rests with the authority having jurisdiction, or OJ, which is typically the local building inspector. The AHJ has the power to require the installation of a grounding electrode even in situations where the National Electrical Code does not explicitly mandate it. This might occur if the AHJ believes that additional grounding is necessary to ensure safety or compliance with local regulations. It is important to consult with the AHJ before beginning any electrical work to ensure that you are meeting all applicable requirements. Grounding electrode conductors play a crucial role in electrical safety by providing a path for fault current to flow back to the source, helping to trip over current protection devices like circuit breakers and fuses. This minimizes the risk of electrical shock and fire hazards. When a panel board is replaced, it is considered a significant alteration to the electrical system, hence the requirement for a new grounding electrode conductor. This ensures that the new panel board is properly grounded, regardless of the grounding status of the old panel. Understanding the specific requirements for grounding electrode conductors is vital for all electricians and electrical contractors. Failing to comply with these requirements can result in code violations, fines, and, most importantly, increased safety risks. Always refer to the latest edition of the National Electrical Code and consult with the AHJ to ensure compliance with all applicable regulations. Furthermore, it's worth noting that the size and type of grounding electrode conductor required will depend on the size of the service entrance conductors. The National Electrical Code provides tables and guidelines for determining the appropriate size of the grounding electrode conductor based on the size of the service entrance conductors. Common grounding electrodes include ground rods, ground plates, and metal underground water pipes. Each type of grounding electrode has its own installation requirements and limitations. For example, ground rods must be driven into the earth to a certain depth, and ground plates must be buried below a certain depth. Metal underground water pipes must be in direct contact with the earth for certain length. In addition to the grounding electrode conductor, it is also important to ensure that the panel board is properly bonded. Bonding refers to the connection of all metallic parts of the electrical system to create a low impedance path for fault current. This includes bonding the panel board enclosure, the neutral conductor, and any metallic conduits or raceways. Proper bonding helps to minimize voltage differences between metallic parts of the electrical system, reducing the risk of electrical shock. The National Electrical Code provides specific requirements for bonding electrical systems. These requirements vary depending on the type of electrical system and the location of the equipment. It is important to follow these requirements carefully to ensure that the electrical system is properly bonded. When working with electrical panels, it is always important to follow safe work practices. This includes energizing the circuit before working on it, using appropriate personal protective equipment, and following lockout/tagout procedures. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Before starting any electrical work, it is also important to inspect the existing electrical system for any signs of damage or deterioration. This includes checking for loose connections, corroded wiring, and damaged equipment. If any problems are found, they should be repaired before proceeding with the work. Ignoring these issues can lead to safety hazards and equipment failures. When adding new circuits to an existing panel board, it is important to ensure that the panel board has sufficient capacity to handle the additional load. Overloading a panel board can cause it to overheat and potentially start a fire. The National Electrical Code provides guidelines for calculating the load on a panel board and determining its capacity. It is important to follow these guidelines carefully to ensure that the panel board is not overloaded. If the existing panel board does not have sufficient capacity, it may be necessary to replace it with a larger panel board. Replacing a panel board can be a complex and time-consuming task, but it is important to do it correctly to ensure the safety and reliability of the electrical system. When replacing a panel board, it is important to disconnect all power to the panel board before starting work. This can be done by turning off the main breaker or disconnecting the service entrance conductors. It is also important to label all of the wires and connections before disconnecting them so that they can be reconnected properly. Once the old panel board has been removed, the new panel board can be installed. The new panel board should be mounted securely to the wall and all of the wires and connections should be reconnected according to the wiring diagram. After the new panel board has been installed, it should be inspected to ensure that it is properly grounded and bonded. It is also important to test the circuits to ensure that they are working properly. Grounding systems also often involve supplemental grounding electrodes. These are additional grounding electrodes that are installed to improve the overall grounding system. Supplemental grounding electrodes can be used to reduce ground impedance and improve the performance of overcurrent protection devices. The National Electrical Code provides guidelines for installing supplemental grounding electrodes. These guidelines vary depending on the type of electrical system and the location of the equipment. It is important to follow these guidelines carefully to ensure that the supplemental grounding electrodes are installed properly. Another aspect of grounding is the use of equipment grounding conductors. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. This includes the metal enclosures of motors, appliances, and other electrical equipment. Equipment grounding conductors provide a low impedance path for fault current to flow back to the source, helping to trip or overcurrent protection devices. The National Electrical Code provides specific requirements for equipment grounding conductors. These requirements vary depending on the type of equipment and the location of the equipment. It is important to follow these requirements carefully to ensure that the equipment is properly grounded. Surge protection is also related to grounding. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power line disturbances, and other events. SPD work by diverting the surge current to ground, protecting the electrical equipment from damage. The effectiveness of an SPD depends on the quality of the grounding system. A properly grounded system will provide a low impedance path for the surge current to flow to ground, minimizing the voltage surge that reaches the electrical equipment. The National Electrical Code provides guidelines for installing SPD. These guidelines vary depending on the type of electrical system and the location of the equipment. It is important to follow these guidelines carefully to ensure that the SPD are installed properly and provide adequate protection. Ground fault circuit interrupters, or GFCIs, are another important safety device that is related to grounding. GFCIs are used to protect people from electrical shock. They work by detecting small imbalances in the current flowing through a circuit. If an imbalance is detected, the GFCI will trip the circuit, cutting off the power and preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. The effectiveness of a GFCI depends on the quality of the grounding system. A properly grounded system will provide a low impedance path for fault current to flow back to the source, allowing the GFCI to detect the imbalance and trip the circuit. The National Electrical Code provides guidelines for installing GFCIs. These guidelines vary depending on the location of the GFCI and the type of circuit. It is important to follow these guidelines carefully to ensure that the GFCIs are installed properly and provide adequate protection. In summary, when working on electrical panels, including adding circuits, retrofitting, or replacing them. Understanding the requirements for grounding electrode conductors is crucial. Remember that adding new circuits or changing feeders generally does not require a new grounding electrode if one already exists. However, replacing the entire panel necessitates installing a new grounding electrode conductor. The AHJ holds the ultimate authority in determining whether a grounding electrode is required, and their decision should always be followed. Always consult the latest edition of the National Electrical Code, review local codes, and speak with the AHJ to ensure compliance and safety in all electrical work.